Hi, this is Hamza. I'm from Sri Venkateswara College of Engineering, currently pursuing my HM in Department of Electronics and Communication Engineering. I'm here to represent a topic on an efficient LoRa-enabled smart fault detection and monitoring platform for the power distribution system using self-powered IoT devices under the guidance of Professor Prakasha sir. Here are the contents of the system. Introduction, literature survey, history of technology, methodology, flowchart, application, results, conclusion, and reference. Introduction. LoRa is a long-range communication provides an energy-efficient way to connect sensors anywhere. Every IoT solution starts with an energy sensor sensing the data and sending the data. Every sensor needs a network for communication. LoRa enables sensors and gateways to send and receive data at extremely low power over long distance, secured and scalable, internationally recognized LoRaWAN standard. Long range and low power consumption and GPS-free geolocation capabilities. An efficient LoRa-enabled smart fault detection and monitoring platform for the power distribution systems using self-powered IoT devices can provide a reliable and cost-effective solutions for detecting and mitigating faults in the power distribution system. In the event of power failure, the service provider remains completely oblivious and to the fact, resulting in the hue and cry from the affected consumers. This lack of feedback also delays in the initialization and reparative and restorative activities and interrupts in the revenue stream of the power distribution operator. Self-powered IoT devices can be used to make the platform more reliable and cost-effective. These devices can harvest energy from the environment, such as solar, thermal, or kinetic energy, to power themselves. The smart fault detection and monitoring platform can use sensors to detect the changes in the power distribution systems. The data can be processed and analyzed in the real time to detect faults or anomalies. History of technology. The history behind an efficient LoRa smart fault detection and monitoring platform for the power distribution systems using self-powered IoT devices can be traced back to the early 2000s when the concept of IoT began to emerge. In recent years, the company and research organizations have been developing and testing such platforms which use LoRa-enabled self-powered IoT devices to monitor power distribution systems. These devices can measure parameters such as voltage, current, temperature, and humidity and transmit this data to a central monitoring system over LoRa network. The use of LoRa technology in the power distribution system began with the development of self-powered IoT devices. These devices are designed to harvest energy from the environment such as solar, thermal, or kinetic energy to power themselves. Here is a literature survey. We have taken as a reference of four papers which were published in IEEE as for the reference published in 2022, 2020, 2019 and 2019. Here is a methodology. Methodology consists of five steps. First step is to define of the problem. The problem is to detect and monitor faults in the power distribution system using self-powered IoT devices. Determine the requirements. This includes the range of LoRa network, the types of sensors and self-powered IoT devices needed, the frequency and for data transmission. Develop IoT devices. Develop the self-powered IoT devices that will be used for the fault detection and monitoring. These devices should be designed to harvest energy from the environment and be able to operate from extended periods without a battery change. Integrate the IoT devices into the system. Once the IoT devices have been tested and validated, integrate them into a system architecture. This includes configuring the LoRa gateway, setting up the sensor, and testing the data transmission. Analyze the data. Collect and analyze the data generated from the system to identify patterns and trends. Here is a block diagram of the system. In this system, the power distribution system is connected to an IoT gateway using LoRa communication. The IoT gateway receives data from multiple self-powered IoT nodes which are distributed throughout the power distribution system. The self-powered IoT nodes are responsible for sensing and monitoring the power distribution system for faults. Each self-powered IoT node consists of a power source, sensors, and LoRa radio module. The power source can be solar panel, battery, or any energy harvesting method. The sensor can be used to monitor different parameters of power distribution system such as voltage, current, temperature, humidity. The LoRa radio module is used for communication with the IoT gateway. The IoT gateway receives data from multiple self-powered IoT nodes and processes it to identify any faults in the power distribution system. The gateway can also send commands to the IoT nodes to perform certain actions such as turning on or off the specific devices in the power distribution system. Here is a plotchart of the system. First, setuping and initialization. After setuping and initialization, the system initially it will be in a deep sleep state. If any interrupt happens, like sensor senses the faults in the power distribution system, then it is detected as an interrupt. Then it will read the sensor value, reads the GPS coordinates, reads the current time, and transmit the data to the monitoring and control center. Here are the applications of the system. In smart cities, ensuring reliable and efficient energy, usually in industries such as the factories, refineries, mines, ensuring uninterrupted power supply to critical equipment and processes. The platform can be used in hospitals, it is used in airports, it is used in military installations. Here are the results of sensor monitoring and the results. The end nodes were assembled, the sketch was compiled and uploaded into the microcontroller through IDE. The Things Network TTN stack LoRaWAN server stack was set up to receive data from the end nodes. For visualization, data was sent to a CANI, which is an online dashboard for IoT applications. The data from format conversion was necessary for CANI to receive data received from TTN. CANI enabled the creation of trigger so that whenever a power outage occurs, an alarm condition was created at the monitoring and control center. Conclusion. Designed to detect faults in the real time and send alerts to maintenance personnel, allowing them to quickly identify and rectify any issues, increased system uptime and reduced downtime, which translates into improved customer satisfaction and lower maintenance costs. The data collected by platform can be used to predictive maintenance, enabling an identification of potential issues before they occur. Provides long range and low power consumption capabilities, making it ideal solution for remote monitoring of power distribution system. The self-powered IoT devices using this platform provide a sustainable and cost-effective approach to monitoring the system. Here are the references for this system, and thank you.